Okay, it's part 252, and it's line 22e10b Neutrons Monte Carlo Martenistic Wow Seti. And this was research was done June 25th, and today's July the 8th, 2012. So here's the WOW alien signal, WOW Seti 1977 alien signal. That's the equation, and that's the answer to it. So we Google the numbers to get this information. So on June 25th, 2012 at 3:30 p.m., I did a Google search from lines 22e10a on Skinful. So this is part 2 of the first video, and then the next one's part 11. Okay, so we're still in line 22e. There are 12 videos so far for this section. So if you want to start with the beginning of this, you want to go to line 22a. Okay. So this is the Google searches for line 22e10a, Google Skinful. So then I put it into a second video because there was so much information. Definition of Skinful. Scintillator full response to neutron detection. Quote, Skinful is designed to provide a calculated full response anticipated for neutron interactions in either an Ne-213 liquid or Ne-110 solid cylindrical detector using Monte Carlo methods. Given a right circular scintillation neutron detector of either Ne-213 or Ne-110, Skinful computes the full energy response of NeVSE, where E is the value of pulse height converted to light units. These units are defined in the program pulse height. Predictions of the code have been compared with measured responses for incident neutron energy between 0.1 and 7.5 MeV, and the predictions are in good agreement with the measurements. And that's from www.oecd-nea.org. And here's a picture here. Kind of looks like, reminds me of shepherd's pie in colors. Okay, so there's the numerical analysis, simulation, data analysis, visualization in the Monte Carlo techniques. Google Monte Carlo techniques. Okay, quotes from Wiki. Monte Carlo methods or Monte Carlo experiments are a class of computational algorithms that rely on repeated random sampling to compute the results. Monte Carlo methods are often used in computer simulations of physical and mathematical systems. Sorry, my lighting here is not too good, so I'm trying to fix it. I've got the sun glaring on it. There, try that. Sorry. These methods are most suited to calculation by a computer that intend to be used when it is infeasible to compute an exact result with a deterministic algorithm. This method is also used to complement theoretical derivations. Monte Carlo methods are especially useful for simulating systems with many coupled degrees of freedom, such as fluids, disordered materials, strongly coupled solids, and cellular structures. See cellular Potts model. They're used to model phenomena. Keeps going white, sorry, with significant uncertainty in inputs such as the calculation of risk in business. They are widely used in mathematics, for example, to evaluate multidimensional definite integrals with complicated boundary conditions. When Monte Carlo simulations have been applied in space exploration and oil exploration, the predictions of failures, cost overruns, and schedule overruns are routinely better than human intuition or alternate soft methods. So I'm going to Google Radiation Shielding Information Center. It's at www.rsicc.ornl.gov. Since its inception in 1962, RSICC has evolved into one of the world's leading resources for a broad range of the best available nuclear computational tools and services. RSICC software and data collections provide in-depth coverage of radiation transport and safety topics encompassing but not limited to Physics of the interaction of radiation with matter. Radiation production and sources. Okay, I don't know what this means. Radiation protection, shielding, radiation detectors and measurements, shielding materials, properties, shields and shipping cask design, radiation waste management, radiological safety and assessment, atmospheric dispersion and environmental dose, radiation dose and medical applications, space shielding applications. Sorry, I'm getting a cramp in my arm here. Yeah, my camera keeps zooming into white and I don't know what's going on with it. I changed some settings on it and trying to make it brighter for you. I think I messed it up. Google Martensite transformation. Quotes data from Wiki Martensite. Iron carbon alloy phases. Ferrite allotropes of ferrite include A for iron, alpha ferrite, whatever that symbol is, delta ferrite, beta ferrite, hexaferrum, gamma ferrite, austentine, Y iron plus carbon in solid solution, cementine, iron carbide, Fe3C, graphite, martensite, metastable phase. Okay, I'm not going to read all these because just look at them there, okay? Talks about the different alloys and steels that come up with this, okay? So martensite, named after the German metallurgist, that word there, Adolf Martens, 1850 to 1914, most commonly refers to a very hard form of steel crystalline structure, but it can also refer to any crystal structure that is formed by displacive transformation. It includes a class of hard minerals occurring as lath or plate-shaped crystal grains. When viewed in cross-section, the lentillar, lens-shaped crystal grains appear acicular, needle-shaped, which is how they are sometimes incorrectly described. June 25th, my thoughts. I see iron and alloys. Then I see crystals. I mentioned a crystal being used for the outside and inside steel frames for the core and shell of the UFO you want to build. That's highly heat resistant. A problem we seem to still have in 2012. The formula idea are based on the keywords are martensite plus hard form of steel crystalline structure plus form plus displacive transformation plus hard minerals plus lath or plate-shaped crystal grains plus cross-section plus lentillar lens-shaped crystal grains plus acicular, needle-shaped. Keywords that stand out: displacive transformation. Google martensic transformation. The martensic transformation, Manfred Allers from Argentina, and that's his email there, allers@cab.cnca.gov.ar if you want to contact him. I'm thinking it's a man. Could be I don't think Manfred's I don't know what. Never mind. I don't know if it's a girl or a guy, okay? The martensic transformation is a diffusionless first-order phase transformation in the solid state, which proceeds by the nucleation and growth of the new phase. It is of importance to understand in which way the coordinated movement of atoms occurs during the transformation. The martensic transformation is a diffusionless phase transition in the solid state with a large diabatic component. What this means shall be illustrated by a simple two-dimensional sketch. Okay, so there's the sketch there. A, B, C. Okay. Figure 1 is a two-dimensional sketch of a martensic transformation from a square lattice to two variants, B and C, which differ only in orientation. And here you go. See this cube thing inside of a cube? Interesting, isn't it? Okay, so figure 2 is the 2-unit FCC cells with a smaller body centered tetragonal cell marked in the center. So this is the type of, this is based on the engineering. You want something to sit inside the middle of this area here. The other one's oblong and this one's circular, right? So by a homogeneous compression in the direction of the arrows and an expansion of the plane normal to it, the BCC structure right is obtained. And then we've got this figure 6 of surface markings due to the formation of martensic plates and Fe and I single crystals. The width of the figure corresponds to 4 millimeters of the sample. Okay. So the stability of the martensite with respect to the high temperature B phase in the noble metal alloys is controlled by two contributions: as electron 1 due to the conduction electrons described by the electron concentration EA, and a configurational one given in terms of pair interchange energies between the atom pairs. Due to the long-range ordering, the Martenistic transformation temperature is lower than that between the corresponding equilibrium phases at elevated temperatures. Many alloys that transform martensitically show the shape memory and superelastic behavior. It occurs if the atoms are allowed to move back during retransformation solely on the same path they had taken on transformation. In the absence of long-range order, generally a multiplicity of transformation paths exists, which lead to the retention of defects after a cycle and thus to an increase in hysteresis. In the presence of long-range order, most of these paths would lead to an unfavorable increase in energy and therefore are prohibited, thus retaining only a single retransformation path, as occurs for the transformation in the Cu-Zn-Al alloys, and in the long-range orders Fe-Pt alloys. And this is www.materia.copyufrj.br. Okay? So next I Google 3-nucleon zero-range theory because I want to know what that means. And it brings up a PDF files and no wiki explanations. Okay? Google correlation, wiki quotes, correlation and dependence. In statistics, dependence refers to any statistical relationship between two random variables or two sets of data. Correlation refers to any of a broad class of statistical relationships involving dependence. So there's the graph it brings up. Okay. It says Pearson-Spearman correlation coefficients between x and y are shown when the two variables' ranges are unrestricted, and when the range of x is restricted to the interval 0, 1. Now what I think of when I see here is x and y come up in the mathematical equations from the alien video 17T2b. It shows up in that one. So if you look in line 17, there's a bunch of formulas or mathematical formulas supposedly from these alien astronauts. And basically I've written down whatever images and stuff I saw and then put them in the video and didn't know what they were. But this brings this back to mind because it says x and y, and it says it's unrestricted. So to me, that's like looking outside of the box, right? And then when the range of x is restricted to the interval 0, 1, that's what you get. So unrestricted, and see what happens. And that's the end of this video. Okay? The next one's going to be line 22e11.